Okay, in today's video, we're going to go over everybody's favorite chemistry topic, stoichiometry. And we're going to I call this grams to grams, because we're going to start with the grams of one of the compounds in our chemical equation, and we want to find the number of grams that we're going to need to react that mass and the mass of each of the products. Okay, so here's our chemical equation. 4NH3 plus 7O2 is going to yield 4NO2 plus 6 molecules of water. All right, you have to remember that the chemical equation shows you a particle, or I like to think of it just as a mole relationship. It's not a mass relationship, okay? But we do want to find the masses of the other compounds or elements in our chemical equation. So you can see in this equation, we've been given that we have 9.75 grams of NH3, and we want to know how many grams of oxygen do we need to react all of that, and therefore how many grams of NO2 are we going to produce, and how many grams of H2O are we going to produce. Okay? Now, there are 3 simple steps that you need to follow, and if you can follow these steps, you can do this stoichiometry problem and just about every other one. The first step is this. We have been given grams, therefore we have to convert from grams to moles, because the chemical equation is a molar relationship, not a gram relationship. If you've been given the moles, which sometimes you will be given the moles, you don't need to do this step because it's already done. But if you've been given grams, which is the typical way to start, then you have to convert from grams to moles. Then, step 2, use the molar ratio to determine the moles of the other substance or the other compound or the other element that you want to figure out the mass for. And then the third one is to convert back from moles of that substance into grams of that substance. Okay? Now, it doesn't matter which mass you've been given. This one, or if we were given the mass of oxygen, the mass of the NO2, and the mass of the H2O, and we want to find all the other masses, it doesn't matter which one. You use the same 3 steps. Okay? So let's go through and let's get started. Okay, first step. We're going to convert from grams to moles using the molar mass. We have been given 9.75 grams of NH3, and you'll see I wrote that down, 9.75 grams in NH3. Write all 3 of those things down, the number, the unit, and the chemical formula. Now we're going to convert. So I like to make this little T-chart. I call it a railroad track. It's not really a T-chart, I don't think. I make a little railroad track. You can put a multiplication sign and a division line. It's the same thing. We want to convert from grams to moles, and we're going to use the molar mass, and we have NH3 on the top, or grams on the top of that one, so we need to put the grams on the bottom. We put the molar mass, 1 nitrogen, 3 hydrogens is 17 grams, and put the mole on the top. That allows us to cancel the grams. We're left with moles, and that is how many moles of NH3 we have, 0.574. Now I'm going to write that down right here. So that reminds me that 9.75 grams is 0.574 moles. Okay? You always have to convert from grams to moles first, because we're going to use this number of moles to solve for the mass, and the mass. We always start with the moles of the substance that we have been given. The next slide. You see I have it right there. The moles, I'm going to write down the moles, because in this case, we're going to figure out first the mass of the O2. So I write that down. Now I'm going to convert. I have done step 1. In step 2, I'm going to use my molar mass to figure out the moles of oxygen. All right? So not the molar mass. I'm going to use the molar ratio to figure out the moles of oxygen. Excuse me. Step 2 is you use the molar ratio. Put down my little conversion chart, my T-chart, my railroad track, whatever you want to call it. Now I have moles of NH3 on the top over here. That means I have to have moles of NH3 on the bottom, so I'm just going to write it down like that. I want to get to moles of oxygen, so I put the moles of oxygen, the thing I want, on the top. And then I look at my chemical equation. What is the molar ratio? Well, it's 4 to 7. So I put the 4 in front of the NH3. That coefficient goes there. The 7 goes there. And now I can do my math, because you'll notice my moles of NH3 cancel, and I'm moles of O2. 5.74 times 7 divided by 4 gives me 1 mole of O2. But I don't want the number of moles. I want the number of grams. So now I'm going to use that to convert using the molar mass of oxygen, which is 32. My moles of O2 cancel, and now I'm left with 32 grams of oxygen. Okay, so that tells me that now I'm going to need 32 grams of oxygen to fully react 9.75 grams of NH3. All right, now we're going to do the same thing for the other two products. Not for the other two products, but for the two products. Okay, you can see we've got our step 1 done. We're going to go through steps 2 and step 3 again. But I'm going to start with the moles of the NH3. That was the thing I was originally given. Yes, I could convert this to moles and use that, but I've already done this, so why do I want to do that? Let's just go on. We're going to convert. We want to get out of moles of NH3, so NH3 goes in the bottom. We want to get into moles of NO2, so the NO2 goes in the top. The molar ratio is 4 to 4, just like that, basically 1 to 1. So you will notice if they have the same coefficient that the number of moles is the same, and we just proved it right there. The number of moles is the same. Now, that was step 2. We used the molar ratio to get the moles of the other material, the other substance, and now we can convert that to grams. We use the molar ratio, molar mass to convert to grams. We want to get out of the moles of NO2, so that goes in the bottom. 1 mole of NO2 has a molar mass of 46 grams. Cancel, cancel, and you're left with 26.4 grams of NO2. So that tells us that if we react 9.75 grams of NH3, and which we would need 32 grams of oxygen, we would produce 26.4 grams of NO2. All right, now let's do the last one. Now this one I'm going to string out in one string, and I'm going to kind of skip the intermediate steps, so to speak. Hopefully you'll see what I mean here. But we are going to once again start with the moles of the original thing we were given, which was the NH3. We're going to now do step 2 again, because we already did step 1 where we figured out it was 0.574 moles. We're going to get rid of the NH3 again, so we put that on the bottom. We want to figure out how many moles of oxygen we need, so that goes on the top. We look at the molar ratio. We can see we have a 4 here, so 4 goes on the bottom. We have a 6 here, so 6 goes on the top. Now I could multiply this out and get the answer. You can see my units cancel, and I'm currently in moles of H2O. I'm just going to continue along because this makes it a little less writing. Now I want to get out of moles of H2O. I'm currently in moles of H2O. I want to get out of moles of H2O, so that goes on the bottom. I want it to be in grams. The grams goes on the top. 18 is the molar mass. 18 grams is the molar mass of water. And I multiply, I cancel these first. You can see now I'm in grams of H2O, and I can see I need 15. I'm going to produce 15.5 grams of H2O. Okay? So that tells me that that is going to be the masses of each of the two reactants, and this is how much of each product I'm going to produce. Okay? If you add these two up, if you add the mass of the reactants up and the mass of the products up, they should be equal to each other, because that is conservation of mass. Whatever mass you put into the equation, you have to get out. And I didn't add these up, but I think I checked it before, and they're pretty close enough. Okay, so if you can check it by adding the two masses on each side, then they should be very close. Now, of course, I could have figured out the mass of the water by just adding up the mass of the NH3, the mass of the oxygen, and subtracting the mass of the NO2. Okay, you could do it that way, but I thought, hey, it's so much fun to do stoichiometry. Let's go through and calculate the whole thing. Okay, so that is stoichiometry. I don't think it's that hard. Follow those steps. Be consistent with your units. Cross your units out. Make sure you got your molar ratios in the right way, not upside down. And I think you will be successful. Okay, thanks for watching. I hope that was helpful. If you thought that was also helpful, give me a thumbs up down there in the comment section. Okay? Thank you very much. Have a nice day.